Hello guys, welcome back to my channel Learn with PR. In this channel, basically we have already started data structure where I am explaining all concept in a simple way and a step by step way. Right? So do like video and share with your friends, subscribe to my channel also, right? And you have to support me. Okay, so I have already published videos on different topics, so you can just go and watch it. Okay, so I recommend you to watch those videos for a better understanding. So if you are a student preparing for exam interviews or just starting programming, this channel will help you to build a strong fundamentals. So do like the video, share it with your friends, subscribe to my channel, and if any doubt, any query, write me and comment. All right, so in this video, we will understand the time complexity and the space complexity. It is very important that how the algorithm taking time as your input size increase. So it always count the number of comparison or steps. Okay, so it's we will not say that we have to check the seconds, we have to count the time. No, we should not. But yes, how much time your algorithm taking to execute some kind of code as the input size grows. All right, so let's start it. So let me take the example of linear search and the binary search. Let's talk about first time complexity. Okay, so assume we have an array of 8 elements. Okay, so when we have 8 elements, so my index will look like from 0 to 7. All right, so we have 10, 20, 30, 40, 50, 60, 70, 80 element. All right, so we have to go comparison, we have to do the comparison. Please watch my previous video. I have already published linear search. All right, so where you will have a full code, right? So you can just go to the code and we'll check how we are doing comparison. So here, so how linear search works basically, first of all, you should know that all elements will, we have to check all elements one by one from the beginning, from 0 to 7. Okay, from 0 index to 7, we have to check all the elements. And if you are searching for the element 70, suppose, so we will go in the first location, then second location, then third, fourth, fifth. When we found the element in, in sixth index, okay, then we have to stop there, right? So this how we can do in a linear search. Okay, so let's do step by step comparison. So if we are saying we are comparing 70, as we are searching 70, we are comparing 70 to this 10. So this will say no, not found. So you will use what kind of loop? Please write on a chat box. Okay, so now when you are searching 70 in a second location, right? That time you will say 20. So it's not present. Okay, so again cross 70 when you want to find in 30 in a location 3, you can say second, you can say. All right, so 30 it's not equal to your search, that means 70, no, so that's wrong. Okay, so you have to go to the next index, that's you can say 3. So 40 is present, so 70 is not. Okay, so again I have crossed here, and then I am checking now 50, I am checking now 60, so it's not. So how many comparison we have did? 6 comparisons so far we have done. Then we will go to the sixth index value. Okay, then what is that? 70, 70 is present, so now it's equal, so we found the element. So how many comparison we have did in this? So 1, 2, 3, 4, 5, 6, 7, 7 comparison, and then we found the element. So 7 times my for loop works actually. Okay, so when we will see the time complexity, so we will see the time complexity analysis as like best case, worst case and average case. So three cases we have, तीन cases में हमें divide करना होता है. All right, so when you are saying 70, you are finding 77th, means you can say what, total 7 comparison you have did. Okay, you have done what, 7 comparison. So when you are doing 7 comparison, that means that you were having 8 elements, 7, so you can say it's a worst case, or you can say average case. Okay, so when you are saying worst case and average case, right, that time the complexity you did comparison 8 times. Worst case means when you are finding 80 element, it want to find 80 element, that time you will go 8 times. That means whatever the number of elements you have, that will be the time complexity of it. All right, so big O, we have to calculate time complexity with the help of big O. Okay, so this is a big O, and means number of elements whatever you have, that you will say worst case. Okay, When you are saying average case, so it's like if we are searching middle element, that means 40. Okay, so when we are going at least 4 times searching that particular element. If you are saying 50, so 5 times. You are saying 60, 6 times, 7, like that way. Okay, so when you want to find that comparison, it's nearly equal to, approximately equal to, you can say n by 2. Okay, so we have to calculate average case as your big O n. All right. So maybe here the elements are 8 now only. Okay. If it is 80, then I want to find, suppose, index which is in the index as 79. Okay, 79 index में रखा है मैंने वो element. I want to search it. So one only, I'm not going ना, means I'm not going only, I'm just skipping one iteration, that's 80 index में whatever the value, we are not checking for that. Okay, that we can't say that this is somehow average, so it's obviously that's a worst, you can say. Okay, so that's why worst and average case contain the same algorithm time complexity as, you can say, big O n. All right. What about the best case? If I want to search the first element, so how many times you will go in the inside for loop? So here only na, if I want to compare 10, suppose, okay, I want to search 10, suppose. Okay, when we are searching 10, okay, then here also 10. So I am now finding the elements. So now these elements, these comparison we have to ignore, obviously. So we have already, we will say here what we found the element. Like, we will not go here. Okay, so how many comparison we did? We did only one comparison. We were comparing 10 only now. So how many comparison? Only one comparison. So you will say that is the best case if you are searching element which is present in first position. Okay, so that comparison is only one, so you will say big O 1. All right, so this is what linear search. So if you now understand this concept, please like this video, okay, and subscribe it. So what is this? So comparison step by step, when you do, you will say only one comparison, that means first element you are searching for. Okay, that means what? The comparison, best case you did comparison 1, so big O 1 only, that's the constant value, you can say. Okay, worst, when you want to search a middle element something, or you can so worst and average case, we have a different. Okay, so worst case when you want to find the last element, average case when you want to find the middle को भी search कर रहे हो ना, that will become the average, or middle, more than middle, you can say, whatever it is. Okay, that is, you can say, comparison you are taking n by 2, that nearly, you can say, approximately equal to your big O n. That's why we always say whatever the worst case time complexity you have, it will become the average case as well. Okay, so we have to take it like that way. So this is a linear search time complexity. Let's talk about binary search time complexity. As we have already discussed this binary search in my video, please check that video also. I will paste the link in the description also. Okay, you can just click and then watch it. Then you will get a clear picture of what binary is and what linear search is. Okay, and where we have to use binary and where we have to use linear search. So the condition says binary search, we have to make our array in a short form. Yes, you have to make it ascending or descending, whatever. But linear search don't contain this kind of condition. All right. So assume if you have array elements 8. Okay. I want to find again 70 here. Same scenario I'm taking here. All right. Now, so in this, what we do in binary search, we divide our array in two parts. So we will get the middle element. Okay. So here middle element, you are saying 3. 3 index is the middle. Okay, 40 is the middle element. All right, so you are searching middle, you are not searching middle, actually you are searching 70. Okay, so you have to check 70 is greater than 40 or not. So you have to go in the second, you can say, right half of your array. All right, when you are going in a right half, that means you have to search here only. So we have to discard looking 0 and 1 and 2 and 3 index. Okay, as you know, it's sorted actually. ठीक है, so आपको पता है जब ये ascending descending form में है, then you have to go in which, left में or right में, you have to choose your ways, right? But we are using this condition here. Okay, so now when we are going here, then we have to check again a middle element. So the new middle element becomes 60, suppose. Okay, so 70 is again greater than 60. All right, so you are going, first you check this one. then you check this one, right? And now you are saying we have to go now in the next half. This half you have, sorry, this half, 70 and 80 half you have to go. Means 70 and 80 in, means 6th and 7th index may you have to check. Okay. Now new middle element become now 70. So now you found the element at 6th index. Okay. But how many comparison you did? One, two, three comparison you did actually. Right? Are you getting our point? So earlier in when we were doing 70, okay, means let me tell you one more time. When we were checking for 70 na here, when we were checking for 70, that time we were doing how many comparisons? Seven comparison actually in linear search. But here you will see we have done only three comparison in a binary search and we got the element. All right. So this is why binary search is faster as compared to your linear search. All right. So this is a simple one to you can see the difference in this video, and you can see with the example of this. All right. Now let's talk about the time complexity of it. Suppose we are saying I want to find 40. Okay, when we want to find 40, not 70, so how many time we will go? We find our middle element here 40. You were searching for 40, so 40 is equal to 40. That means you find the element now. So means only one comparison you did. You did how many comparison? You did only one comparison. When you want to find the element middle 40, okay, there is only one time your loop will execute. So what is when we are saying only one time we are going, that means the best case you find actually, right? So when you already say what big O one means, big O one is what means you are searching for middle element. Okay, you are searching for 40 actually. All right. So this is how we can say this is how many comparison. Only one comparison you will say, and it contain big O one best case. All right. Suppose when you want to search 10, suppose, okay, when you want to search 10, okay, or maybe that element which is not present. Okay, so if you want to search the first value, first position value, and maybe the element not present, that you can say the worst case. How many times you will do that comparison? You have to comparison till you know you found the element, found the first index value, okay, and you can say that element not present. Okay, here that we were talking about, if I want to find 70 also, okay, if I want to find 70, how many comparison we did? Three comparison actually. Okay. So whatever the number of elements you have, that time you will check that what is the middle element. Then you have to go right and left according to your condition, according to your element you want to check. Okay. So total comparison you did three times. So at least you will say 70 when you are searching, that you can say the average case, because 70 is somehow you can say like in the no not a last element. So you will say the average case. When you want to search 10 element or maybe 80, right, that time you will say you search at least three again you have to do the three comparison, the same comparison you will do. But there was the element 8 only, okay, but if it is 80, then how many times you will say? Okay, so that you should understand it, that we are taking a small element. So you can take if large 800, suppose 800 80,000 element you have in your array, then how you can search, you know? So that time, so how it's becoming big O log n? Basically you divide it now. So when you are searching for 70, suppose, okay, so you divide it, so you are not checking for these elements. So when you are skipping some kind of iteration, right, some kind of elements you are skipping, you are not checking for it, that means you are skipping some part. So that you will say their log n time complexity will be there. Okay, when you want to when you have already skipped the some iteration, that time log n will help you. Logarithm time complexity we will get. So logarithm n, so whatever number of elements you have, so when you will say log 8, that means when you will check that value log 8 की ना value आप check करोगे तो 3 ही आएगी, 3 आएगी. Okay, 3 time. So that's why we are doing 3 time comparison. ठीक है. So when you are saying worst case, that means you want to find the first element, and the algorithm complexity will looks like big O log n. All right, 10 you want to find. Average, still we divides our array, so comparison somehow will be big O log n. As for 70, Okay, so three comparison we were doing. So here also three comparison. Okay, so this is a time complexity for your binary search. If you understand the concept, please write in a chat box. Any confusion you have, please write in a chat box. Please like and subscribe to my channel. Okay, now let's talk about the final comparison with example. When we were checking for some element, linear search we were doing, binary search we were doing. So linear search may we were searching for 70 element, right? 70 element we were searching. So seven comparison were there. In binary, we were having three comparison. Okay. So with the help of these comparison, you were checking element three and seven comparison you were checking, you were getting in a linear search as well as binary search. So that means less comparison, the faster algorithm looks like. Okay, so this is a clear picture why binary search is faster than your linear search. It basically eliminates half elements in every step. That's why we reduces before comparison हमें नहीं करना पड़ रहा. That means it's saving your time. Okay. Okay, now, so linear search and binary search time complexity. So you can say best is big O 1, okay? Average is big O n, and worst is big O n, okay? And in a binary search, you will see what best case is big O 1, okay? Average case is big O log n, okay? This is big O log n, okay? And worst is also big O log n, okay? So this you will simply remember it, okay? And if you will not remember, if you can't remember it, then what you can do, you can simply do this kind of thing here, okay? So that's on you. All right, so this is all about your time complexity. All right, now let's talk about the space complexity. So space complexity means what? How much extra memory an algorithm uses while it is running, while you are executing your program, how much memory taking actually, okay, that algorithm. So it also includes some extra variable, temporary variable, and function call stack also for recursive. When you do recursive function means recursion जब आप use करते हो recursive function call itself again, so that time also stack में save होता है. So for that also you have to take what memory, okay? So you have to calculate that also, okay? It does not include any input size, okay? Whatever input size you can take, you can take 1000 10 uh, 10,000, whatever it is, okay? So space complexity also measure your additional memory as well, whatever the program requires or algorithm requires, okay? So let's talk about how you can find out space complexity. So space complexity, basically, let's talk about the linear search first, okay? Okay, so first check the linear code, then you will get it. Okay, this one, because why? What is I? What is key? What is found? है ना? That you will check. Previously video you have to check. Okay, beta. I will paste that thing in the description. So here I key, and key means search you are doing. Found means you found the element or not. You are checking. So some extra memory you are using. That means I means loop counter you are using, key element search you are using, found. They will also store some kind of memory in your computer. Yes. So extra variable you have taken three. Okay. Now, even if the array size change as n 10, n values is n value is what 10 elements 10 आप डाल रहे हो 1000 डाल रहे हो 1 lakh 1 crore whatever 10 crore whatever it is. Okay. So number of extra variable remains same actually. ओके. सो मतलब इसमें टोटल जो एक्स्ट्रा वेरिएबल आपने लिए वो थ्री ही है. तो थ्री इज अ कांस्टेंट ना. ओके. एंड आई टोल्ड यू अर्लियर दैट वट एवर array size you will take, it does not basically include. Okay, so you are taking even this thing as well. So number of extra variable remains same actually. Okay, so the space complexity for your linear search is 1, big O 1 you can say. Okay, that's a constant. So linear search basically uses a constant amount of extra memory. So its space complexity is what? Big O 1. All right. So this is a simple way to understand it. So it doesn't matter that you are using for loop how many times. So time. So it will take time complexity, not space. Okay, space का कोई matter नहीं करेगा. All right, now let's talk about binary search, how you can find out binary search space complexity. So with the help of two ways actually you can do binary search. Okay, so iterative, one is iterative basically, and second is a recursive. recursive function, when you are creating a recursive function. Okay, so here also I have written low, high and mid. For that you have to check the previous video. Only that previous video you will get to know what low, high and mid. Okay, so you are taking low, high and mid elements, right? So extra memory used means low, high, mid, but the constant numbers variable na. Okay, so space complexity in iterative binary search will be big O 1 only. So iterative binary search also uses extra constant memory, you can say. So its space complexity become the big O 1. Okay, now let's talk about this binary recursive with the help of recursive function. So when you are creating a function, I told you earlier also that when you are using some extra variable, temporary memory, or you can say stack, function call stack for a recursive algorithm, recursive function. Okay, that time it takes memory. Okay, so let's talk about how. So when you are calling your function, okay, when you are calling your function, so recursive call, whenever the function is calling, recursive function is calling, so it will store all calls. When it means 5 times you are calling your function. Okay, so um, all calls will be stored in your stack. So whatever number of calls, okay, whatever the number of calls, maybe if you have n as 8 element. Okay, so how many time it will call? 3 times na. Comparison कितने हो रहे थे जब 8 elements थे? Three comparison was there. Okay, so that's what I'm saying, that when you are having number of elements 8, 3 times it will call. So now it's taking log n actually. Okay, why? You are skipping some iteration, obviously you are calling 3 times. Okay, so when you are calling 3 times, so 3 times your stack will hold that memory actually. Okay, if you are having number of elements 16, then how many times? 4 times. When you have number of elements in an array 32, how many times it will call? 5 times. Okay, so the space complexity for your recursive function will be log n. Why it is? As your number of elements increasing, your space will also increase, because your recursive function, whenever it's calling, it will store that thing in a stack only. So stack बढ़ता रहेगा ना, one by one it will call, right? So when you are saying this, that means it will take time complexity big O log n. So recursive binary search uses stack memory actually for recursive call means recursive function calling, whenever you are calling. Okay, because recursive call itself again ना, so वो एक बार loop चलता रहेगा उसके अंदर. It's kind of loop. You are not using looping, but it's kind of loop recursive function. Okay, recursive function is like a function. Sorry. So recursive function is like what? Like it will call until unless condition become false. All right. So big O log n it will be. Okay. So when you are saying binary search space complexity, make sure you have to write two things: iterative and recursive. Okay. So in iterative you will say big O 1, and in a recursive you will say big O log n. So this is also a simple example, like why number of calls is approximately equal to your log n. So binary divides basically two halves में divide करता है. So every time it will divide, right? So size reduces also, right? मेरे पास पहले 8 एलिमेंट्स थे. ओके, देन 4 हो गए क्योंकि मैंने डिवाइड कर दिया, फिर 2 हो गए, फिर 1 हो गया, लाइक दैट वे. सो नंबर ऑफ डिवीजन आपने 3 बोले है ना, राइट? सो पहले वो 8 एलिमेंट थे, फिर 4 ही रह गए, फिर 2 ही रह गए, फिर आप एक ही सर्च कर रहे हो, राइट? सो इट टेक्स कॉल्स 3 टाइम्स, सो इट विल टेक log n. ओके, if it is 16, then it will say 16 elements are there. You will find mid element, then you will check here where to go, left to right, left or right. We have to go where, right? So if you will go in a right side, again you will get 8 elements. Okay, if you go left side, again you will get 8 elements, and then again you further divided 4 and 2 and then 1. So how many times division are there? 4 times. So 4 times stack will hold the memory. So log n will be the will be the space complexity of it. Okay, so here also 32 if you have, so 5 times you will divide it. So stack will call 5 times actually. Okay, so recursive binary search requires big O log n space due to recursive function call stored in the call stack. All right, so I hope you got this concept, how to find in a linear search and binary search that space complexity as well as time complexity. So here also a quick comparison table I have created for you. So in algorithm, if you are saying linear search, extra space you are taking constant. That means the space complexity become what? Bigger one. Okay. Now, if you are saying binary search iterative way, okay, that time you will say extra constant you are using. That means bigger one. Page complexity become bigger one. But in a recursive binary search, if you are doing, that means that holds a stack memory actually. So stack will take big O log n. Okay. So if an algorithm uses a fixed number of extra variable, its time complexity become big O one. And if it uses recursion, okay, recursion अगर use कर रहा है तो extra space it will take from the stack, it will also increase that space time complexity. Okay, so I hope you like this video, you understand the concept. Okay, so if you like this concept, please do share with your friends also, right? So in my next video we will understand that how to insert new element in the array step by step, and it will be very easy. Okay, so if this video helped you to understand the concept, please like, share and subscribe to my channel Learn with PR. Your support really motivates me to create more code oriented content. So thank you so much. We'll meet in the next video. All right. So if you have any kind like this video, share with your friends and subscribe to my channel. Thank you so much.